Okay, we're going to talk about some trig applications. Some of these are easier than others. Basically, we're applying everything we've learned to these problems. So I'm going to do a few examples, and then we're going to work on some in class. Lots of problems go with a right triangle. It can be a ladder leaning up against a building. It can be the angle that you're seeing something tall. It could be a shadow problem. Lots of problems. So let's just go over how to solve for all sides and angles. First of all, the angle should be fairly obvious. That's going to be the one at 180 degrees in every triangle. Subtract the 90 is the right angle, and subtract the 34.2, the given angle. Our missing angle is 55.8 degrees. If I'm solving for sides, I've got to know that opposite of my given angle is A. Adjacent is given to me, 19.4, and my hypotenuse is unknown. So I've got to solve for two sides. To get opposite, I've got this angle. I'm going to go from what's given. I want to find opposite. I'm given adjacent. Only one trig function fits that. That's tangent of the angle. 34.2 equals opposite over adjacent, which is 19.4. Solving for opposite, that's going to be 19.4. I'm sorry. So opposite is going to be 19.4 times the tangent of 34.2. Make sure your calculator is in degrees when you are punching this in. So that makes my opposite side come out to be 13.184. Do not round on anything until you get to the very end, and then round to 3 places. Okay, if I'm setting up trying to find the hypotenuse, I'm given the adjacent. I want to find the hypotenuse, so that's going to be a cosine. Cosine 34.2 equals 19.4 divided by the hypotenuse. Solving for the hypotenuse, I'm going to get 19.4 divided by cosine 34.2. Again, make sure you're in degrees. Should come out to be 23.456. Another way to use trig in real life is talking about bearings when you're talking about navigation. Basically, a bearing is telling a pilot or a captain which way to go. So, for example, down here, this is south 35 degrees east. From the south direction, I'm 35 degrees east. This one is north 80 degrees west, so from the north direction, I'm going 80 degrees west. North 45 degrees east, I'm going 45 degrees east of the north direction. Okay, take a minute, write this problem down, write the picture down. Picture might be even more important than the words. A ship leaves port at noon and heads due west at 20 knots, or 20 nautical miles per hour, until 2 p.m. Then he changes course to north 54 degrees west, and then for another hour. Okay, so what this is already showing you is 2 hours at, and this should have 20 nautical miles per hour right there, which equals the 40 nautical miles total. Then they change his directions, and for one more hour at 20 nautical miles per hour, he's going 20 more nautical miles. So, question, find the ship's bearing and distance from the port of departure. We want to know this distance and this angle. So So let's look at this picture and pick out what we can solve for. Let's see. I know the 54 degrees. So I know I can figure out this angle because that's 90 minus 54. So that's going to be 36 degrees. And I know the hypotenuse right there is 20. So I can solve for the adjacent side by using cosine. Cosine 36 equals d over 20. So now d becomes 16.181 nautical miles. Solve for opposite by using sine 36 equals b over 20, which b comes out to be 11.756 nautical miles. So now I need you to remember to keep these numbers stored into your calculator so you can recall them, because we do not want to round anything until the very last answer. So now if I look at the big picture, I've got my theta here. I know the length of this long side is 16.181 plus the 40, so 56.181. I know b, 11.756. So now I can use tangent equals the 11.756 divided by the 56.181. And then I would solve for theta by doing tangent inverse of that number. Again, exact numbers, do not round until the very last when you get your angle of, what's it come out to be? Comes out to be 11.819. But we probably want, no, we do want the angle from the north. So I'm going to subtract that from 90 and get 78.181 degrees north. It's north, 78.181 degrees west. 78.181 degrees west of north. To solve for the hypotenuse, I would just use my two sides that I solved for, use Pythagorean theorem. Don't round to the end. You get 57.397 nautical miles. Alright, we got our two answers. Was there more than one way to go about this? Sure, this is just one example. Okay, let's talk about harmonic motion, another way trig is used in the real world. This one is talking about a ball at rest. You pull it down, it's being pulled down a fixed distance, it retracts up a fixed distance, so you can see the curve that would happen over time. This screen is just the words. Suppose 10 centimeters is the maximum distance. The ball moves vertically upward or downward from equilibrium. The time it takes for the ball to move from its maximum displacement above zero to its maximum displacement below zero and back again is 4 seconds. And we assume there is no interference. So here's the formulas for harmonic motion. Since our ball is going down, retract back up and back down, we're going to say this is an inverted sine, so we're going to go with this one. Harmonic motion, A and W are real numbers. W is Greek for omega. The amplitude or motion has an amplitude A. In our case, that amplitude would have been that 10 centimeters. Period, 2 pi over W, and frequency W over 2 pi. Okay, this tells us the period is 4 seconds. What is the frequency? So if you look back at the previous screen, it told you in the little box that frequency is omega over 2 pi. So we need to figure out what omega is in order for this to work. And the box also said that the period equals 2 pi over omega. So period equals 2 pi over omega. We know the period is 4 seconds. 2 pi over omega. Multiply omega over, that's going to give you 4 seconds. Don't really need the S in there. So 4 seconds times omega equals 2 pi. So omega equals 2 pi over 4. Omega is pi over 2. If I put that into frequency, omega, pi over 2 over 2 pi, it's going to take me to 1/4. And that should be 4 right there. So 1/4, it's completing 1/4 of a cycle per second.